A podiatrist makes soft and hard inner soles for patients' shoes. The inner soles are made from plastic that is set in the lab. Each inner sole takes time to construct and time to fit. She's got 800 centimeters cubed of plastic available and allocated a maximum of 60 hours to construction and 5 hours to fitting the inner soles. The soft inner soles use 100 centimeters cubed of plastic, take 6 hours to construct and 12 minutes to fit. The hard inner soles use 40 centimeters cubed of plastic, take 4 hours to construct and 24 minutes to fit. So, if we let S be equal to the number of soft soles, and we let H be equal to the number of hard soles, it seems that the constraints are on the amount of plastic, the construction time, and the fitting time. So we'll look at those in a moment. But first consider that we have non-negativity, so we must have greater than or equal to 0 for S and greater than or equal to 0 for H. Now let's look at plastic. We've got 800 in total. The soft takes 100 and the hard takes 40. So that's going to give us 100S plus 40H is less than or equal to 800. And of course we could cancel this down. Everything here divides by 20 to 5S plus 2H is going to be 800 divided by 10 is 80, so that's going to be 40. Now let's look at the construction time. We've got 60 hours that we can give to construction. Each soft one takes 6, each hard one takes 4, so that's 6S plus 4H is less than or equal to 60. We could cancel that one as well, to 3S plus 2H is less than or equal to 30. And then finally, let's look at the fitting time. So she can give 5 hours, but these are actually given in minutes. So 5 hours is 5 times 60, so that's going to be 300 minutes. So for the soft, it's 12. So we've got 12 minutes for those. And then there's 24 minutes for the hard ones. So that's got to be less than or equal to 300. And once again, we could cancel this one down. So we need to plot the constraint lines. 5S plus 2H is 40. So if we had H was 0, S would be equal to 8. So that's going to be just here. If S is 0, H is 20, which is off the grid, so we need to use a different value. Let's take S is 4. If S is 4, then this is 20 plus 2H is 40. So 2H is 20, H must be 10. So that's going to go through the point for 10, which is just here. So that's our first one, just like so. And we can label that one. So that one was 5S plus 2H is equal to 40. Now for the second one, if we take H is equal to 0, that means that S would be 10. So that's just here. Once again, we've got a problem with making s equals 0. H would be 15, which is off the top. So choose a different value for s, say 4. S is 4, that's 12, so therefore 2h would need to be 18, so h would be 9. So it's 4, 9. It's going to be a point on that line. So that's going from there through there, like so. Let's just label that one. So that was 3s plus 2h is 30. And then finally, s plus 2h is 25. So if s is 0, h is going to be 12.5, which is just here. Now, once again, we haven't got s equals 25 over here, so let's take, say, h is 10, and then s would be 5, so it's going to go through this point here, like so. And lots of space to label this one. So that's s plus 2h is 25, and that gives us this region here when we include the non-negativity as well. So it's going to be this region down here. Now, each soft sole is 100 profit and a hard one is 80. So our profit function is going to be 100s plus 80h. Vertices are 0, 0. The other integer one over here is 8, 0. Then up here we have 0, 12.5. Now these other ones are not easy to find on this grid. So, for example, if we're trying to find this one just here, that's the intersection between this line and this line. So if we solve those simultaneously on the calculator, we'll find this here. Of course, you could solve simultaneously without the calculator. And it turns out that that one there is at 2.5, 11.25. So we've got 2.5, 11.25. And the final one is 5, 7.5. And if we evaluate the profit at each of those, we get 0, 1,000, 1,150, 1,100, and 800. But of course, we've got a problem just here that these are not integers. We can't produce half an insole or 0.25 of an insole. So what we need to do is take some nearby integer valued coordinates, such as 1, 12 and 3, 10 and 4, 9, 5, 7, 6, 5. So those are close to where we found the solution was. And we found the solution before was at 2.5, 11.25. So we're looking around here, but we need to look close to these other vertices as well, which is why we've got things like 5, 7 and so on. So what do those give us? This one gives us 1,060. This is 1,100. Then we've got 1,120. We've got 1,060, and we've got 1,000. So our best one is this one, and that tells us to produce 4 of the softs, 9 of the hards, and we'll get $1,120 profit. We now have a new concept, the concept of slack. Slack is all to do with the amount of one of our resources that isn't being used at the optimum point. And remember, we've just found that our optimum point was 4, 9, and that corresponds to S being 4 and H being 9. If we look at the fitting time, this was the inequality for that, and we have to go to the original one, not the cancelled down one we used for plotting. So substitute in, and we've got 12 times 4, because S is 4, add 24 times 9, and that's less than or equal to 300. That gives us 264 is less than or equal to 300. The slack is the difference between these two numbers. So 300 take away 264 is 36 minutes. So there'll be 36 minutes of fitting time that won't be being used. Now, if we look at the plastic as well, so this was the inequality for that. So that's going to be 100 times 4 plus 40 times 9, and that was less than or equal to 800. And this one comes to 760. And so we can see that there are 40, and that would be centimeters cubed, of plastic that isn't used at this optimum point. By how much can the profit on soft soles increase before the number of soft and hard soles to be manufactured must be changed to maximize the profit? So this is a sensitivity question. Now at the moment we're using 4, 9, which is around here. And we need to look back at some of the others that were being used, but we're increasing the profit on this one, on the S. Remember, the current profit was 100S plus 80H, and we're going to use a new profit of K, so that's going to be KS plus 80H, because this one's not changing. But if we want to improve this one, if S is going to improve in terms of how much profit it gives us, that means that we'll want to do more soft soles and potentially less of the hard ones. We may not need to. So what we need to do is look at the vertex that we used that's in this direction, because we're going to be increasing the profit on S. So there was a point that we used earlier, 5, 7, which is going to be the nearest one to the 4, 9 we're currently using, but that's the nearest one in the direction where we increase S. So this is the point that we want to test. When is this one going to change over to this one? So we're looking at going from 4, 9 to 5, 7 using this new profit. So when are they equal? So that's going to be the profit on 4, 9 equal to the profit on 5, 7. So this one is S is 4, so that's going to be 4K plus 80 times 9. And this one would be 5K plus 80 times 7. So that's 4K add 720 is 5K plus 560. So rearranging that a bit, that's going to give us that K is equal to 720 take away 560, which is 160. So this would be the new profit on S, and that's an increase of $60 because the current is $100.